take a bit for it to send the data. I'm streaming on Twitch. Hey, there we go. Let's pop out chat. Right, YouTube. That's the thing. And this time I'm not gonna fuck up. That was a decision I made, to be clear. I think it's funny when I fuck up and thus make mistakes on purpose. Right, where's my channel? Do I exist? Hello. A. Gotta get that YouTube. Yeah, but she's small. She doesn't deserve to be any larger. Okay. Looks quite well. Gonna close out a few things. Gonna talk to myself in order to fill the empty space. In order to stop myself from thinking about my issues and problems, average, ordinary, everyday stuff. Did not do this last week, and I do apologize for that. I also didn't tell anyone like the other guy does, like Noah does. That was an embarrassment, and I do apologize for that. Still, though, fun. Oh, wait, I haven't been reading this. Are people actually reading it together? That is very good. Sorry, I have had zero time to do basically anything recently. Gladly, though, I will be doing this today. I'm gonna wait a few minutes in case anyone actually does come in. Perfectly fine. If they don't, though, I'm just gonna truck along. Where were we, though? What were we doing? Ah, we finished this last time. That's good. This might be a shorter one, might be a longer one, who knows? I don't think I'm gonna get too far. We might get through this and the other one, but I doubt we'll be getting too far into this. Showing how to test a run. Okay, this is going to be just looking for this commands, or only we can select how many threads, of course, that makes sense. Okay. Would this be useful for seeing how our application works at lower thread counts? Would that just be for testing? To use to test the binary. Okay, yeah. That wouldn't just be from compiling. That would be for testing. That's good, though. Showing function outputs. Just gonna quickly look at this, see how she goes. We've currently been here 24 seconds. No idea why it goes negative at one. That's honestly terrifying. Look, I don't know what to say right now, man. I'm tired. Incredibly tired. Ignoring some tests unless specifically requested. Oh, okay. We can have just some tests that don't need to be run on every single account. I guess in case it's only a test that could run well, I guess here it says explicitly that it's for an expensive test, but I don't know, man. I see other uses for that though. You could run it only if it's compiled to use these behaviors. I wonder if you can set logic in here to only run the test if compiled in a certain way with certain flags. We'll see though. Who knows? This is going to be a very boring chapter. Incredibly boring. Or an incredibly boring page, I guess. That's really short. Good to see. In about 2 minutes we will be starting, or perhaps shorter than that, because I do want to get started on this. I did miss last week, and again, I don't want to be doing that. That makes me sad. I'm trying to get X Defiant to run for the past 20 minutes has not been working out well for me. Not going to be able to play it, but somebody asked me if I could figure out how to get it to work for them. Not working out too well for me, man. I don't know what to talk about in these sections. If I were an editor, I'd cut this all out. Anyway, I'm just gonna start reading, man. People here or people aren't. This isn't going to be a very important chapter. Controlling how tests are run. Just as cargo run compiles your code and then runs the resulting binary, cargo test compiles your code in test mode and runs the resulting test binary. The default behavior of the binary produced by cargo test is to run all the tests in parallel and capture output generated during test runs, preventing the output from being displayed and making it easier to read the output related to the test results. You can, however, specify command line options to change this default behavior. Some command line options go to cargo test, and some go to the resulting test binary. To separate between these two arguments, you list the arguments that go to cargo test, followed by the separator dash dash, and then the ones that go to the test binary. So anything before the dash dash, if it exists, will go to cargo test. Anything after will go to your test binary. Running cargo test help displays the options you can use with cargo test, and running cargo test dash 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 help displays the options you can use after the separator. Running tests in parallel or consecutively. When you run multiple tests, by default, they run in parallel using threads, meaning they finish running faster and you get feedback quicker. Because the tests are running at the same time, you must make sure your tests don't depend on each other or on any shared state, including a shared environment, such as the current working directory or environment variables. For example, say that each of your tests runs some code that creates a file on disk named test-output.txt and writes some data to that file. Then each test reads that data in that file and asserts that the file contains a particular value, which is different in each test. Because the tests run at the same time, one test might overwrite the file in the time between another test writing and reading the file. The second test will fail, not because the code is incorrect, but because the tests have interfered with each other while running in parallel. One solution is to make sure each test writes to a different file. Another solution is to make sure each test writes. Another solution is to run the tests one at a time. If you don't want to run the tests in parallel, or if you want more fine-grained control over the number of threads you use, you can send the dash dash test threads flag and the number of threads you want to use to the test binary. Take a look at the following example. Right, but what if inside of your test there is multi-threading? What if you write multi-threading into the test, and then you use dash dash test dash threads equals 1? Does that mean that the test will still run 1, 1, 1, 1, like one after the other? However, the multi-threading will still work perfectly fine? Or separately, does that mean that you are limited to one core, and thus the default behavior of your application under a situation where there is only one thread, single-threaded behavior exists? So what's going on there? We have set the test number of test threads to 1, telling the program not to use any parallelism. Running the test using one thread will take longer than running them in parallel. The tests will not interfere with each other if they share state. That's not described. I'm going to look into shit. Okay, don't look at that. Fuck. Do not look at that. I can explain. No, I can't. Ignore that. Right, what is that? Alright, that's quite useful. What do we have? We are looking for test threads. That doesn't exist here. That's very useful. Thank you very much. Okay. I guess there's no information here. Why? Wait, did I misinterpret this? Why did I misinterpret how this works? What is the separator? Did I misinterpret this? You know what? I don't care. By default, if a test passes, Rust test library captures anything printed to the standard output. For example, if we call print line any test and the test passes, we won't see the print line output in the terminal. We'll see only the line that indicates that the test passed. If a test fails, we'll see whatever was printed to the standard output with the rest of the failure message. As an example, listing 1110 has a silly function that passes the value of its parameter and returns 10, as well as a test that passes and a test that fails. Just a moment. We have function prints and returns 10. This doesn't work apparently. This go panics. Yes, it does. The print line prints out the value of A and then returns 10. Tests, super. Yep, we can see what's going on. When we run these tests, we'll see the following output. Running 2 tests. This will fail, failed. This will pass, it passes. Wow. This test will fail, standard output. I got the value of 8, as seen here. Thread, panicked at assertion, fail, left equals right. Left was expecting 5, right got 10. Right, yep. So as you can see, if it passes, we do not get any output. If it fails, we do get output. Good to see. Note that nowhere in this output do we see I got the value 4, which is what is printed when the test that passes runs. The output has been captured. The output from the test has failed. I got the value of 8 appears in the section of the test summary output, which also shows the cause of the test failure. If we want to see printed values for passing tests as well, we can tell Rust to also show the output of successful tests with -- show output. Cargo tests -- show output. Okay, I did fully misunderstand what the -- did. That's not passing over to the application. I don't care what it does though. When we run the test in listing 1110, again with the -- show output flag, we see the following output. Right, so this will show the output in both cases. The success is the standard output from test. This test will pass. Got the output value of 4. Success. This test will pass. Failures, and here's the failure again. Right, running a subset of tests by name. Sometimes running a full suite can take a long time. If you're working on code in a particular area, you might want to run only the tests pertaining to that code. You can choose which tests to run by passing cargo test the name or names of the test you want to run as an argument. To demonstrate how to run a subset of tests, we'll first create 3 tests for our add_2 function, as shown in listing 1111, and choose which ones to run. We have a public function add2. We have a test, mod test, test add2, test add3 to 2, so on and so forth. Run the test without passing any arguments, as we saw earlier. All the tests run in parallel, as seen here. Running a single test, we can pass the name of the test to cargo test to run only that test. Right? So we can just have the name of the function. That is the test. Quite useful, fairly easy to understand. Only the test with the name 100 ran. The other 2 tests didn't match that name. The test output lets us know we had more tests that didn't run. to filter it out at the end. We can't specify the name of multiple tests in the way, only the first given value to cargo test will be run. But there's a way to run multiple tests. Filtering to run multiple tests. We can specify part of a test name, and any test whose name matches that value will be run. For example, because two of our tests name contain add, we can run those by running cargo test add. Will this work with regex? Probably not. I recently learned that cargo doesn't include regex by default. This command ran all tests with the add function in and filtered out the rest. Also note that the module in which the test appears becomes part of the test name, so you can run all the tests in a module by filtering on the module's name. Ignoring some tests unless specifically required. With the ignore, we can see that. I'm going to read this. You probably don't need to. Sometimes if you use you might want to exclude them from the tests. Rather than listing all arguments tests you want to run, you can instead annotate a time-consuming test using the ignore attribute to exclude them. After test, we add the ignore line. Now when we run it, it doesn't work. The extensive test function is listed as ignored. If you want to run only the ignored tests, we can say, hey, run all the ignored tests. By controlling what tests you run, you can make sure your cargo test results will be fast. When you're at a point where it makes sense to check the results of the ignored tests, and you have time to wait for the result, you can run -- ignored instead. If you want to run all tests, -- include ignored. When running a cargo test with no additional configuration, which of the following actions may not work correctly if done by multiple tests? Logging strings to standard output always will work. Writing text to a single file will fail. Failing file panic will always work. Reading data from a single database. That's just reading. It'll be fine. Consider a program with the following unit tests. Test the logger, test the database, test the logger and the database. What is the shortest string you have to pass to cargo test, such that only test the logger and test the database are executed? Okay. V. Probably V. Probably not even V. It's probably TH. Sure. That's probably a fail. What is it? H. Wow. What a useful tool. Well, that's gonna happen a lot, right, guys? We're gonna just be patching in H all the time. That's incredibly dumb. That's useless. Who cares? Sorry for the ganker in this moment. I understand. I really don't understand why this is here. Why do we need to know that H is the shortest that can run? I mean, sure, there's no H in this. Sure, whatever. That's meaningless. Who cares? Test organization. As mentioned at the start of this chapter, testing is a complex discipline, and different people use different terminology and organization. The Rust community thinks about tests in terms of two main categories, unit and integration. Unit tests are small and more focused, testing one module in isolation at a time, and can test private interfaces. Integration tests are entirely external to your library and use your code in the same way any other external code would. Using only the public interface would potentially exercising multiple modules per test. Writing both kinds of tests is important to ensure that the pieces of your library are doing what you expect them to, separately and together. Unit tests. The purpose of unit tests is to test each unit of code in isolation from the rest of the code to quickly pinpoint where code is and isn't working as expected. You'll put unit tests in the source directory in each file with the code that they're testing. The convention is to create a module named tests in each file to contain the test functions and annotate the module with CFG test. Yep. The CFG test annotation on the test module tells Rust to compile and run the test code only when you run cargo tests, not when you run cargo build. This saves compile time when you only want to build the library and save space in the resulting compiled artifact because the tests are not included. You'll see that because integration tests go in a different directory, they do not need to be inside of the CFG test annotation. However, because unit tests go in the same files as the code, you'll use CFG tests, you specify that they shouldn't be included in the compiled results. Recall that when we generated the new adder project, in the first section of this chapter, Cargo generated this code for us. Yep. This code is the automatically generated test module. The attribute CFG stands for configuration and tells Rust that the following items should only be included given a certain configuration option. In this case, the configuration option is tests, which is provided by Rust for compiling and running tests by using the CFG attribute. Cargo compiles our test code only if we actively run the test with cargo tests. This includes any helper functions that might be within this module, in addition to the functions annotated with test. Private function testing. There's debate with the testing community about whether or not private functions should be tested directly, and other languages make it difficult or impossible to test private functions. Regardless of which testing ideology you adhere to, Rust privacy rules do allow you to test private functions. Consider the code in listing 11.12 with the private function internal adder. Alright, we have internal adder, which is a private function. We have a new module called test, CFG, using super, using this namespace. We can test it. Correctly. Yep, internal adder will work. Assert equals. There's no crab here to tell us, oh no, she broke. Alright, that is good to see. I personally stand in the camp that if you're going to test everything, you should test everything. Why wouldn't you test a private function directly? That would make the most sense. Why not test it directly? Indirectly testing a private function can lead to some mistakes and issues, errors even. Why not test correctly? Note that the internal adder function is not marked as pub. Sorry, I can understand why a private test not being tested directly makes sense, but personally I do disagree. Note that the internal adder function is not marked as pub. Tests are just Rust code, and the test module is just another module. As we discussed in the past for referring to an item in the test tree section, items and child modules can use the items of their ancestor module. In this test, we bring all of the test module's parent items into scope with use superstar. And then the test can call internal adder. If you don't think private functions should be tested, there's nothing in Rust that can compel you to do so. Okay. Integration tests. In Rust, integration tests are entirely external to your library. They use your library in the same way any other code would, which means they can only call functions that are part of your library's public API. Their purpose is to test whether many parts of your library work together correctly. Units of code that worked correctly on their own could have problems when integrated, so test coverage of all the integrated code is important as well. To create integration tests, you first need a test directory. The tests directory. We create a test directory at the top level of our project directory, next to source. Cargo knows to look for the integrated test files in this directory. We can then make as many test files as we want. Oh, thank you. Look, man, I can make more than you can handle, trust me. I know the NTFS limit. And Cargo will compile each of the files as an individual crate. Let's create an integration test. With the code listing in 11.12, I'm not going to be writing this on my own. I don't care that much. Still in the source lib.rs file, make a test directory and create a new file named test/integration-test.rs. File structure should look like this. Good stuff. Enter the code in listing 11.13 into the integration-test.rs file. Alright, here we are. You know what, fine. Fine. What day do we not have? We have day 7. We're now day 33. We're now day 77.7. Good. Who cares? Cargo. New. Is this supposed to be an adder? I don't. I actually don't care that much. We are supposed to be writing this. It has test function. It adds to assert equal for adder equals 2. We're using this function within here. You add 2 to 2. Each file in the test directory is a separate crate, so we need to bring our library into each test crate scopes. For that reason, we use adder at the top of the code, which we don't need in the unit test, because this is already within scope. We don't need to annotate any code in test/integration underscore test.rs with CFG tests. Cargo treats the test directory specifically and compiles files in this directory only when we run cargo test. Run cargo tests now and get this output. Right. Okay, one pass. It looks fine. We have a test. It adds 2. Okay. Is there any other information that we haven't been gaining? Nope, that's fine. 3 sections of the output includes the unit tests. Oh, I guess that's it. Yeah. So we have running one test, internal. Running one test, I guess this is external. It's not explicitly stated that this is a unit and this is an integration test, which makes sense. It may not be. I understand that's likely how it should be, but I see no reason why we couldn't run unit tests here. However, yes, we see that this is internal. Good to see. And the doc test. So we have those 3 sections. Note that if any tests in a section fails, the following section will not be run. Okay, so if the unit test fails, won't be any integration or doc tests. For example, if unit test fails, there won't be any input for those 2 things, because the test will only be run if unit tests are passing. First section for the unit test is the same as we've been seeing. 1 line for each unit test, 1 named internal. And we added in listing 11, 12. Oh, okay. Yeah, so internal wasn't actually something run there. It'll just, yeah, so this will always be the integration. This will always be the, what is it called? Unit test, and then this will always be the doc test. It doesn't actually say anything in here to specify that, but we'll just have to remember, I guess. Which is okay. I see no issue with that. It'll always tell us which test failed. And a summary line for the unit test. The integration test section starts with the line running test/integration test.rs. Next, there is a line for each function in that integration test and a summary line for the results of the integration test just before doc test adder section starts. Yep. Each integration test file has its own section. So if we start to add more files into the test directory, there will be more integration test sections. We can still run a particular integration test function by specifying the test name as an argument to cargo test. Run all tests in a particular integration test file, use --test argument of cargo test, followed by the name of that file. Cargo tests --test integration test. Command runs only the tests in the test-/integration underscore tests.rs file. Sub-modules in integration tests. If you add more integration tests, you might want to make more files in the test directory to help organize them. For example, you can group the test function by the functionality they're testing. As mentioned earlier, each file in the test directory is compiled as its own separate crate, which is useful for creating separate scopes to more closely imitate the way end users will be using your crate. However, this means files in the test directory don't share the same behavior as the files in the source do, as you learned in Chapter 7 regarding how to separate code into multiple modules and files. Into modules and files. The different behavior of test directory files is most noticeable when you have a set of helper functions to use in multiple integration test files, and you try to follow the steps in separating modules into different file sections of Chapter 7 to extract them into a common module. For example, if we create test/com.rs and place a function named setup in it, we can add some code to setup that we want to call from multiple test functions in multiple test files. Setup right here. When we run the test again, we'll see a new section in the test output, the common.rs file. Even though this file doesn't contain any test functions, nor did we call the setup function from anywhere. All right, yep, we have internal. I don't see where it is. I don't see where it is. Oh, he's gone. Yep. Having common appear in the test results when running zero tests, with running zero tests displayed for it, is not what we wanted. We just wanted to share some code with the other integration test files to avoid having common appear in the test output. Instead of creating test/common.rs, we'll create test/common/mod.rs. The project directory now looks like this. Test common mod.rs, creating a new module. This is the older naming convention that Rust also understands that we mentioned in alternate file path section of chapter 7. You know, I'm really glad that this will in fact work differently. It says that this is the older way and that the newer way is what normally comes into play. But it seems that they are changed, they are different, they have separate behaviors. Naming this file this way tells Rust not to treat the common module as an integration test file. That's incredibly annoying. If I were to start using the normal way, I would expect this behavior. But no, the old way is a different behavior. And what if somebody wanted that to be an integration test? Will that no longer be an integration test in any way, shape, and or form if they're using like a folder selection like this? Alright, whatever. Name the file this way tells it not to create, yep. When we move the setup function code into test common mod.rs and delete the test common.rs file, the section in the test output will no longer appear. Files in the subdirectories of the test directory don't get compiled as separate crates or have sections in the test output. After we've created test common mod.rs, we can use it from any of the integration tests as a module. Here's an example of calling the setup function from the itAdds2 test in test/integration test.rs. Use adder mod common. We have tests, function, itAdds2. We're using common setup, and simply using adder add2. Note that the mod common. Oh, okay, yeah. Note that the mod common declaration is the same as the module declaration we demonstrated in chapter 7.21. Then in the test function, we call the common setup function. Integration tests for binary crates. If our project is a binary crate that only contains source main.rs and doesn't have source lib.rs, we create integration tests in the test directory and bring functions defined in the source main.rs file into scope with a use statement. Only library crates expose functions that other crates can use. Binary crates are meant to be run on their own. This is one of the reasons Rust projects that provide a binary have a straightforward source main.rs file that calls logic that lives in source lib.rs. Using that structure, integration tests can test library crate with use to make the important functionality available. If the important functionality works, a small amount of code in main and source/main.rs file will work as well. And that small amount of code doesn't need to be tested. But I'm fairly certain under that condition you still could test it via unit testing. Integration tests wouldn't work, but unit tests would work, but integration would not. No apologies needed, that was what I wanted to say. Summary. Rust testing features provide a way to specify how code functions. Words are a difficulty for me. I can't really talk right now, and I apologize for that. Rust testing features provide a way to specify how code should function to ensure it continues to work as you expect. even as you make changes. Unit tests exercise different parts of a library separately and can test private implementation details. Integration tests check that many parts of the library work together correctly, and they use the library's public API to test the code in the same way external code will use it. Even though Rust type system and ownership rules help prevent some kinds of bugs, tests are still important to reduce logic bugs having to do with how your code is expected to behave. Let's combine the knowledge you learned in this chapter and in previous chapters to work on a project. Alright, which of the following is not a good reason to wrap unit tests in CFG tests, mod tests? User tests access to private functions, that's not a good reason. It separates small helper functions from library code. Nope. It can improve compile time, or it can reduce. Not a good. Oh yeah, that is going to give you access to private functions. Well, no, it won't. I don't know actually. It can reduce the size of generated compiler artifacts. They didn't talk about that. It can improve compile times. They didn't talk about that. It separates test helper functions from library code? Correct. Alright, let's just say this. That's incorrect. What's the correct answer? It gives your test access to private functions. Well, actually, no, it won't. That is correct. It won't give it access to private functions. You need to use the super, and it needs to be within that test. All unit tests in a given file have access to that file's private functions, regardless of being mod tests or not. Okay. How was I supposed to know that it reduces the size of generated compiler artifacts? I mean, obviously it does. Because if you compile it, these are not being built. I don't know, man. Who cares? Right. We finished that section and are now going into a project which we will be building. Okay, that's actually really good, but I'm not going to be doing that today. This is going to be an incredibly short one. It's only been 34 minutes. But I think this will be fun for other people to go through. I'm going to read how this works, and I'm going to set up the project file. I don't know what it's going to be called. Let's see if there's anything that's going to be called. Okay, so we'll make it tomorrow, I guess. Oh, sorry, a week from now. An IO project building a command line program. This chapter is a recap of the many skills you've learned so far and an exploration of a few more standard library features. We'll build a command line tool that interacts with file and command line input-output to practice some of Rust concepts you now have under your belt. Nope, no quizzes. It's supposed to be a hands-on walkthrough. Rust speed, safety, single binary output, and cross-platform support make it an ideal language for creating command line tools. So for our project, we'll make our own version of the classic command line search tool grep. Globally search, a regular expression, and print. In the simplest use case, grep searches a specified file or the specified string. To do so, grep takes as its arguments a file path and a string, and reads the file, finds lines that in that file that contain the string argument, and prints those lines. Along the way, we'll show how to make our command line tool use the terminal features that many other command line tools use. We'll read the value of an environment variable to allow for the user to configure the behavior of our tool. We'll also print error messages to the standard error console stream, standard error, instead of the standard output, stout. So, for example, the user can redirect successful output to a new file while still seeing our error messages on screen. One Rust community member, Andrew Gallant, has already created a fully featured, very fast version of grep called ripgrep. By comparison, our version will be fairly simple, but this chapter will give you some of the background knowledge you need to understand how a real-world project such as ripgrep works. Sure. Our grep project will combine a number of concepts you've learned so far: organizing code, using vectors and strings, handling errors, traits and lifetimes where appropriate, and writing tests. We'll also briefly introduce closures, iterators, and trait objects, which chapters 13 and 17 will cover in detail. This is a fairly chunky one and will take multiple days to go through. It's an exciting one though, that's quite good. Right, so we are going to create a new area, a new thing. Cargo cargo new mini grep. Alright, I wish it would CD us into mini grep. Alright, here is our thing, the stuff even. Alright, we'll call our project minigrep to distinguish it from the grep tool that you may already have on your system. The first task is to make minigrep accept 2 command line arguments, the file path, and the string to search for. You know what? I think we are going to go through this page because it's only been 40 minutes. We're going to stick to an hour for this session. A, there's nobody in here, and B, this is quite an interesting one. This may be the last one that anyone comes to, but you know what? It's definitely not going to be the last one I go to. Well, I guess the last one would have been the last one anyone comes to. Either way. Cargo new minigrep. The first task is to make it accept 2 command line arguments. That is, we want to be able to run our program with cargo run. 2 hyphens to indicate the following arguments are for our program, rather than for cargo. A string to search for, and a path to a file you want to search in, like so. Cargo run dash dash string search string example file name .txt. Right now, the program generated by Cargo new can't process arguments we give it. Some existing libraries on crates.io can help you writing a program that accepts command line arguments. But because you're just learning the concept, let's implement it ourselves. Reading the argument values to enable minigrep to read the values of command line arguments we pass to it, we'll need the standard env args. Okay. std and that's not what we want. Args. I see why that didn't bring it in. So I forgot the use statement. Fair. Oh, we're just using standard env. Makes sense? That's what happens when you go forward without reading. We'll cover iterators, right? Providing the standard library. This function returns an iterator of command line arguments passed to minigrep. Cover it more in 13. Now, you only need to know 2 details about iterators. Iterators produce a series of values, and we can call the collect method on an iterator to turn it into a collection, such as a vector, that contains all the elements the iterator produces. The garden listing 12.1 allows your minigrep program to read any command line arguments passed to it and then collect the values into a vector. Use standard env. Fantastic. Right, now we have let args, which is a vec of type string. Type string, wow, thank you. Equal n args dot collect. Fantastic. Then we're going to debug it. We're just going to debug args in its entirety. Fantastic. Now we don't need that. Let's run it. I'm guessing that's what they want us. Well, that's definitely not what I wanted to do. Right, so that would be cargo. Run. And let's add in some arguments. -f, -l, -- ratio. Right. Here it is, printing the debug information of target debug minigrep with an f plus l plus ratio. Fantastic. Alright, first, we bring the standard env module into scope with a use statement so that we can use its args function. Notice that the standard env args function is nested in two levels of modules. As we discussed in Chapter 7, in cases where the desired function is nested in more than one module, we've chosen to bring the parent module into scope rather than the function. By doing so, we can easily use other functions from standard env. It's also less ambiguous than adding the use, standard, and args, and then calling the function with just args, because args might be easily mistaken for a function that's defined in the current module. Make sense? Note that standard and args will panic if any argument contains invalid Unicode. If your program needs to accept arguments containing invalid Unicode, use standard and args-os instead. A function returns an iterator that produces OS string values instead of string values. What is an OS string value? We've chosen to use standard env args here for simplicity because OS string values differ per platform and are more complex to work with than string values. On the first line of main, we call env args, and we immediately use collect to turn the iterator into a vector containing all values produced by the iterator. We can use the collect function to create many kinds of collections. So we explicitly annotate the types R, the type of args, to specify that we want a vector of strings. Although we very rarely need to annotate types in Rust, collect is one function where you do often need to annotate, because Rust isn't able to infer the kind of collection that you want. Finally, we print the vector using the debug macro. Let's try to run the code first, with no arguments, and then with two arguments. Okay. Let's just cargo run this mode. Yep, we do still get one argument, which is the location which you had ran this from. Can't remember. Let's actually try that. Well, no, I can't do that, can I? I don't have that set up. Whatever. Okay. So first off, we have target debug minigrep. Second off, we have needle and haystack. Oh, that's quite funny. I like that. Yeah, that's quite fun. Notice that the first value of the vector is target debug minigrep, which is the name of our binary. This matches the behavior of the arguments list in C, letting our program use the name by which they... no, this is... Yeah, that's the program that ran this, kinda. It's also... Sorry. Letting programs use the name by which they were invoked in their execution. It's often convenient to have access to the program name in case you want to print it in messages or change behavior of that program based on what command line alias was used to invoke the program. Really? Okay. But for the purpose of this chapter, we'll ignore it and save only the two arguments that we... I've never seen an argument ask me to change the alias. To change functionality. Is that a commonality? That'd be very weird. Saving the argument's values in variables. The program is currently able to access the values specified as command line arguments. Now we need to save the values of the two arguments in variables so that we can use the values throughout the rest of this program. We do that in listing 12.2. Standard, environment, function, main. Let args, yep, we got that. Let query equal the first argument. Well, the first argument passed through the second argument in the field. Let file path equal the third option in the args vector, which is, yeah. Right. We are going to be writing this. I forgot that we are, in fact, programmers, not readers. Let query equal the redirection of args in square brackets 1. Fantastic. And secondarily, this is going to be 2. That's going to be the file path. Fantastic. Wonderful. And we're just going to print them both out. I fully accept that this will in fact work. I have not tested it, but I am a rebel. You've seen last session how terrible of an idea that is. I probably fucked up even something that simple. But you know what, if I did, it's a good learning lesson. Well, no, it's not actually. But you know, I'm lazy. As we saw, when we printed the vector, the program's name takes off the first value in the vector args 0. So we're starting arguments at index 1. The first argument minigrep takes is the string we're searching for. So we put a reference to the first argument in the variable query. The second argument will be the file path. So we put a reference to the second argument in the variable file path. Is that a reference? No, that's a dereference. No, that's a reference. It's a reference, not a dereference. I'm an idiot. I'll always make that mistake, man. We temporarily print the values of these variables to prove that the code is working as we intended. Let's run this program again with the arguments test and sample.txt. Right, yep, searching for test in file sample.txt. This is not a great way to do it. No, this is fine for the way that we want to do it. Yeah, that's fine. Personally, though, I prefer explicitly. I would prefer dash search for dash in file or something like that, but you know, that's not even how grep works. I'll admit that's not a great behavior. Great, program works. Values in the arguments we need are being saved in the right variables. Later, we'll add some error handling to deal with certain potential erroneous situations, such as when a user provides no arguments. For now, we'll ignore it and work on adding file reading capabilities instead. All right, that's it for today. Goodbye.